In this video, I'm going to tell you everything about graphing quadratic equation and properties. Everything you need to know about quadratic equation graphing. So, first of all, how do we recognize if we are dealing with quadratic function or not? So, the quadratic function has the highest degree two, right here. If it's anything else, the highest degree, if there is a degree higher than 2, then it's not a quadratic function. Okay? Next, we know that not every graph represents function. How do we know if the graph of quadratic equation, that is parabola, represents function or not function? So, if I have here, let's say, not bad, but still use your imagination, it's supposed to be symmetric. Okay, so if I provide vertical line, okay, and it turned out my every x on this graph via vertical line will match only one y, or cross the graph only in one the spot, then we have function. Which means anywhere on this parabola, if I provide vertical line, it's going to cross in one point only. But if I draw the parabola in this format, let me see. If I draw the parabola in this format, and if I test it using the vertical line, what do we see? That vertical line is crossing in 2 points. Correct? That means this graph is not a function. All right? So to recognize if this is a function, we have to use vertical line testing. All right? If it crosses in more than one spot on the graph, then it's not a function. Now, why such a requirement? What's the importance of this requirement? Why not vice versa? If it crosses in more than 1 point, then it is a function. If it's crossing in only 1 point, that is not a function. There is a reason to that. Everything is done for a reason. Let me explain why we need only crossing in 1 point. For example, let's assume okay, so the student is going to school, and school is located. What was that? Try one more time. On this distance, S of t. So, and this is t, time, and s is a distance. So starting from a home, which is 0 point, let's say student is going to university, yes? Okay. Coming to university. Okay, it's there. The student is there. Okay, staying at university for some times, which means doesn't go anywhere, right? Distance is the same. And then going back home. Okay, so we have T1 at the point T1, right here at the distance S, the student reach the getting to university and then stays till T times T2 and at time T3 coming back. So what is interesting? On the way back, so let's say the student can be on the same distance twice. When it's going, let's say S of T0, here this is I call T0, and this one will be T0 prime, for example. And it's on the same distance, right? One is when the student is going to university, the other one when student is coming back. It's on the same distance. But with the student cannot be at the same, at different, at the same time at two places. Let's say if it would be, go to school at time T1, it cannot be on the distance S of T0 and S of T. See the vertical line, if I provide, it's crossing 2 points, right? This point, it's crossing this point and crossing this point. So at the same time, T1, the student cannot locate it on a distance, at a distance S of T and S of T0. We understand? This is why we identify a function, the graph, where vertical line is crossing only in one spot. Otherwise, we would see that at, let's say, the T1 is, for example, at 3 p.m. So at 3 p.m., it's an S of T0 is equal, for example, 5 miles. S of T is equal, let's say, 7 miles. So at 3 p.m., student cannot be 5 miles away from home and at the same time at 7 miles away also. But it can be twice on the same distance at different time. Okay? This is why function, it's the graph when it's crossing a vertical line in one spot only. Okay. Now, let's assume we don't have a graph of the quadratic equation, but we do have in the sense of coordinates of the graph. So let's assume we have number 2. For example, we have -1 and 1. Let's say we have 3 and 9. Let's say we have -1 and 4. And we have -3 and 9. So those are, let's say, coordinates of some function, and we want to identify if this is a function of those, but these coordinates represent function or not. So we are looking at our x that if our same x has two y's. If the same x has more than one y, that means it's crossing the graph in more than 1 point. And therefore, it's not going to be, this coordinate do not represent function. So here I have -1, -1, and it's crossing 1, and it's crossing 4. So which means it's if this is my, let's say, -1, this vertical line is crossing at the point y is equal 1 and y is equal 4, right? So let's say our graph goes like that, and which means it doesn't represent function. Okay. Next, let's see. Next property, I would like to talk about quadratic, the function. It's symmetry. Question number 3, symmetry. Quadratic function rather saying function of quadratic equation, is symmetric about y-axis. Okay? Is symmetric about y-axis. Now, if I move my graph either to the right or to the left, let's say I moved here. If I moved by -a, then it's going to be symmetric to x is equal, symmetric to x is equal -a. Right? Here is symmetric to y-axis, that is representing x is equal 0. Because x, when a graph of x is equal 0, it's a y-axis. All right? Next, I would like to talk about the even, the function is odd or even. Odd, even, neither. Okay. The rule for the odd function is f of -x is equal f of x. That's, I mean, for even function, I'm sorry. That's a rule for even function. The rule for odd function, f of -x, is equal -f of x. That is odd one. Neither one when neither the condition satisfied, and it's neither case. Okay, our graph is y is equal x squared, and its parabola obviously is even y, because we said if I take positive x or negative x, y is going to be the same, right? Because why? Because f of x is nothing else but y. So let's take it. Let's say I'm taking this negative x, I'm taking this, this negative x and this positive x. If you can see, they share the same positive y, which means f of negative x, it's going to be same f of positive x. Okay, so it's the graph or the function is even when it is symmetric about y-axis. When it is symmetric about y-axis. All right? What will happen if I shift it? If I shift it to the right this time, this graph, this function will stop being, same shifted by positive a, will stop being even function. Why? Because it's not symmetric to y-axis. It is going to become symmetric to x is equal a graph, right? X is equal a. So this one is not even. Remember one thing. At the second you shift it horizontally, right or left, it will stop becoming even function. Now let's talk about domain and range. Let's talk about domain and range. Domain is identified by all values of x that can be or exist on the graph. Okay? And it's represented, domain represented by x. Range represented by y, all possible y values on the graph, on the parabola. Let's assume, how do we identify domain? Very easy. Let me explain. We have here graph. And let's say this is part of parabola. And here I have empty circle, the end, and here I have full circle. Empty circle meaning it's not included, full circle, solid circle meaning it's included. So let's assume this is, how much is this? 1, 2, 3, 4, 5, 6, about 7. And this one, it's going to be about 5. Yeah? And this is also this is going to be 3. And this one, let's say, is 2. Okay. So domain is represented by a value of x that laying on this graph. Let's see what values of x. Where is the beginning? Where is the end? Beginning of this graph where x is equal from the point of x is equal 2, and ending with x is equal 7. So for the domain, it's going to be represented. And one thing we need to remember, first goes smaller number, second goes higher number, always. Okay, so 2 and then second. Now, at the point of 2, we have empty circle, which means 2 is not included. We put parentheses. But at the point of 7, we have solid circle, which means 7 is included. We put square brackets. Okay? Now let's see what y and what kind of y, what values of y has this graph, beginning and end. So let's see. This empty circle has coordinate of y equal 5, and the ending starting circle and ending circle, that is solid circle, it has a value of 3. Okay, so we have it starts at 5 and ends at 3. But 3 is a smaller number, so therefore we are going to put 3 first and then 5 second. Plus 3 is included because we have solid circle, so it's going to be square bracket. And 5 is going to be empty circle, which is 5 is not included. I put parentheses. And this is your range. Let's do a couple of other cases. Let's do this one. Graph here, y-axis here, now x-axis here. Let's assume now my graph looks like this. Okay, this one is full point, this one is circle. Okay, so assuming this is 1, then this is 3. And what is the range here? We have here, how much? 1, 2, 2.5, okay. 2.5, and this one is 0.5. Okay, so what's going to happen to domain? Domain, it's a value of x. We have 1 and 3. Since 1 is smaller number than 3, first we start with 1 and then bigger number 3. 1 is a solid, we put square brackets. 3 is an empty circle, we put parentheses. Now let's look at range. It's going down, right? And it starts with 0.5 and ends with 2.5. Since we have here solid point, although one is empty, but the other point is solid, then 0.5 is going to be included. I'm using smaller point, 0.5, and then I'm using ending point that is higher, 2.5. And it's going to be square bracket also. All right? Another interesting case, I have, let's say, arrows. Arrows meaning running to infinity. This is, for example, is 5, okay? but I don't need values of x because it's running to infinity, right? So domain, what's going to happen here? This is infinity. This is running to infinity. This is heading to infinity. So where is it going? If it goes, it will keep going to negative. It's keep going to, this one is positive. So domain is going to be from negative infinity to positive. Every value of x, it's going to include negative infinity to positive infinity, because it's starting from negative infinity. It's negative infinity smaller, then we put first negative infinity, and then we put positive infinity. Okay? Yeah, because infinity doesn't have limit or is not included. Therefore, infinity use only with the parentheses, always. Now, regarding the range, we see here is the limit 5, but where is it starting? It's starting at infinity, right? It's negative infinity. It's starting from negative infinity. One point is negative infinity, right? Then second point is 5. So I'm going to put, because we put the smaller number first, I put negative infinity, parentheses. And then second one, I'm putting 5 and put square bracket. And if I have graph like this, let's say, and let's assume so let's assume my graph goes like this. So what do we have here? The graph is running to infinity, right? So it's running from negative infinity, domain is running again from negative infinity to positive infinity, right? Because it can't start positive infinity, run to negative. It starts with negative infinity and then slowly touching here 0 and then running to the y touching 0 and then running to positive infinity. And the range, one is positive infinity, right? It's going up. And the other one is, where is this point for y? It's a 0, correct? On the level of 0. So it starts with 0, and 0 is included, because 0 is smaller than positive infinity. I put 0, and infinity goes positive, and it's going to be included in parentheses. All right? Okay. Now, let's talk about steps and analyze about vertex. First of all, the original, the fundamental graph for the function, for the quadratic function is, it's a standard form, is ax squared. Let me write down standard form is ax squared plus bx plus c. But we can break down into factoring, and we can get non-standard form, which is going to be a times x plus h squared and then plus k. Let me do this. Red color, and with blue, okay, red color. And with the blue, I'm adding here minus because it can be positive or negative, and k also positive or negative. Okay, this one also make red. Okay, so first let's start about vertex and properties of x squared, other properties of x squared. So as we know, the standard form of the graph is look like this one. Okay. So if I want to draw standard form of the graph, it's going to be y is equal x squared. And as we can see, entire graph is laying on the positive side of y. Why is that way? Because we have x squared. You take x positive, you take x negative, you will end up positive number. This is why we are our entire graph is located in the positive area of the y-axis. Now, the graph can run up or the graph can run down. Can run down. Okay. Let's assume I have can run down. So when graph is running up, then this point we call the lowest one. Then the graph is running down, then this point is the highest point. This lowest point and highest point we call vertex. Okay? Parabola always going to have highest point or lowest point, and therefore we are going to deal with vertex. That's a first one of the important steps, one of the important points we need to know to build the quadratic, the function of quadratic equation. So I'm writing down steps. Now, don't hold me accountable for the order. Order is not important which one you do first. Calculate first. So one of the steps is vertex that we need to know. Next, we have x squared. Next, I can build, see we have everywhere a in the original form, ax squared plus bx plus c, or a times x plus h squared plus minus k. So a is a coefficient of our x squared that is showing that we are either stretching or shrinking the function. So y is equal ax squared. So how this a affect the parabola? If this is my x squared, So my, let me write down x squared, which means a is equal 1, right? Okay. Next, I'm going to build, if I have parabola like this, closer, that is getting closer to y asymptote, we have, let's say this is gonna be 2x squared. 3x squared will be even at a shrink more. So until it will grow too big, right? And it will fold this parabola, because it's symmetric, it will fold across the y-axis and become straight line. Okay? Now, also, I can have the graph that's laying lower than lower than 1x squared, that is one, let's say 1/2 of x squared. Okay, so which means the smaller get coefficient, the more it's gonna stretch. Okay, it's gonna stretch until it will get so small, right, that it will become the horizontal line. It will take the position of x. Okay, so which means y will be equal 0 here. It will become 0. All right? So, now what if we have, if this is when a is positive. A is positive, greater than 0. Now, what if we have a is less than 0? When it's less than 0, then parabola gonna go down. By the way, when a is greater than 0, all these graphs have vertex that is minimum, yes? Okay. Now, let's look when a is less than 0. So I'm starting with negative x squared. So the negative x squared, it's like you take x squared and reflect about x-axis, which is gonna look like, I'm choosing the same color, and it's gonna look like, no, that's not the right, let's say it this way. So this is going to be negative x squared, where a is going to be negative 1. In this case, negative 1. Now, to build negative 2x squared, it's going to shrink more. Okay, and for negative 1/2, it's gonna stretch. So as you can see, it's a mirroring down, like when you're looking in the water, it's like mirroring. So it's gonna be negative 1/2 x squared. So this is for the case when a is less than 0. Pay attention for the graph, for the parabola, parabola of quadratic equation. In this case, the vertex is going to be maximum point, right? So for when a is greater than 0, let me write down a greater than 0, vertex is minimum. A is less than 0, then vertex is maximum. Okay, So we built their vertex. Next step, we need to figure out, once we've calculated vertex, I will show you in what case how you figure out vertex. Next step is going to be our coefficient A. Okay? Coefficient A. Next, we are going to intercept, X-intercept. Let's understand something. Let me draw the graph. I can have the graph that will have two x-intercepts like this. I can have a graph of function that has only one intercept. With x. And I have a graph, I can have a parabola that will not have any intercept with x. Okay? And the same way when a is less than 0. 2 points, 1 point, 1 intercept, or 2 intercept. And I'm going to explain to you how we're going to figure out, without solving anything, how we can going to figure out how to find out these intercepts. So next step, it's going to be intercepts, x-intercept. Next, since we can have y-intercept, let's say my graph is going like this. It has y-intercept here. Or my graph can go like this. Let me see. It will have y-intercept here. Okay? So we need to find also y-intercept. All right. So those are points that we need to know, be it a standard form or be it non-standard form. Order is not important at all. You can you can work with any order, okay, because they don't depend on each other. So we are going to figure out every single point there, 1, 2, 3, 4, and then put together our graph of the quadratic function. And we are going to build standard form and non-standard form. I'm going to start with non-standard form because it's a little bit easier. And then we move to standard form. All right. So let's start with non-standard form of quadratic equation. So we have y is equal twice x minus 1 squared and minus 3. So comparing to this standard form, this is going to be a times x plus h squared and plus k. Okay? So what do we have? Okay? I always start with x squared, period. Because that's a standard form, our fundamental form, fundamental graph, x squared for parabola. And this is y is equal x squared. There, at the next, my a is equal to, right? A is equal to so I'm going to graph a x squared. That's going to be next step. So first I'm building x squared. Next I'm building a x squared. So 2x squared. Okay, let me put here also with specific data. 2x squared, right? Next, I'm going to build x minus 1. X minus 1, that's a change of x. As we know, every time when the whatever sign that shifting of x has, we are using opposite one. Why is that? Because if I have twice, let me do drafting, twice x minus 1 squared equals 0. Then from here, x minus 1 squared equals 0. X minus 1 is equal 0 and x is equal 1. Okay? So therefore, if it's given negative 1, we are shifting towards positive 1. If it's given positive 1, then we are shifting towards negative. So we always move to the opposite sign. So it's going to be, let me clean this. So this 2x squared, I'm moving to the right by 1. Let's say this is my 1. I'm moving by 1. So this blue color, solid blue color, taking and moving by 1 to the right. If this is our 1, so this solid blue color, it's going to look like this. So this is going to be twice x minus 1 squared. So let me make sure this minus 1, it's a change of x. And minus 3 is change of y. And keep in mind, you always, when it's come to change of x, you always move to opposite direction. Why? Because if you have, let's say, twice x minus 1 squared is equal 0, from here x minus 1 squared equal also 0, x minus 1 is equal 0, and x is equal positive 1. So you practically moving by 1, while it's given negative 1. X is always shifting to the opposite side, but y, a change of y, it's going to go directly. What you see, that's what you shift by. Okay, so moving down by 3. 1, 2, free. And let's use red color. So it's gonna be let me use thicker. And this is our twice. Okay, this is too thin. Twice x minus 1 squared minus 3. Guess what is this? This is vertex. And that's a minimum, right? With the coordinate. X is 1. And y is negative 3. And without graphing also, looking at the quadratic the function, you can say if it's x minus 1, then you are taking positive 1. Here is minus 3, you are taking negative 3, and that is going to be your vertex. Now, if we want to find out values of x's, we need to solve it. Value of x, and at any point on the x-axis, our y is going to be 0, which means twice x minus 1 squared minus 3 is equal 0. From here, twice x minus 1 squared equal positive 3. X minus 1 squared is equal 3 over 2, right? We divide by 2. And x minus 1 is going to be equal plus minus square root 3 over 2. Why? Because we have square, we need to take square root on both sides. X minus 1 squared, x minus 1 will come out. Square root of 3 over 2, it's going to be approximately 1.23 or 24. X minus 1. From here, x minus 1 is equal positive 1.24 and x minus 1 is equal negative 1.24. So from this one, 1 plus 1.24, x is equal 2.24, which is going to be this position. And this one, x is equal positive 1 minus 1.24, x is equal negative 0.24, which is going to be this position. Okay, if we want to find out y-intercept, so those are, let me write down, x-intercept. So we take y is equal 0, and we get y-intercept 2.24, and 2 is negative 0.24. Now, at the y-intercept, for y-intercept, we have to take x is equal 0. So when x is equal 0, what do we get here? Y is equal twice 0 minus 1 squared minus 3. Okay, that is y is equal. So negative 1 squared is 1, 2 times 1 is 2, 2 minus 3, it's negative 1. So, well, it didn't go precisely, but this point is supposed to be negative 1. Okay? There we go. So that's our y-intercept. So we found vertex. We know that A is our 2, which is positive. And we have y-intercept. Here we found it. And we have, y-intercept, negative 1, and x-intercept. Okay? Let's do next one. what do we have? Next one is gonna be y is equal negative 3 times x plus 2 squared. Okay, let's see how we're gonna solve this one. So what do we have? We have 8 times x plus h squared and then plus k, which in this case we have 0, right? Okay. So we start with x squared. Now our a is negative, right? A is equal negative 3, which means I have to flip it down to get negative at the 3. So if I flip it down, that will be my negative x squared. Okay? Negative x squared. So negative 3, it's going to be closer to y-intercept. This is going to be negative 3x squared. Next, I'm going to use shifting of x. Since I have x plus 2, I'm going to shift by negative 2. Okay, so if this is 1, this is going to be 2. I'm going to shift by negative 2. No. Okay. Let me see, maybe this one I can change. All right. So this is going to be my negative 3 x plus 2 squared. This is negative 2. And that's it. Since I don't have my k 0, I don't move anywhere. And this is going to be my next graph. So this will have only one point here on x, and that's going to be a vertex. And because graph is looking down, then this is going to be maximum, right? Vertex is going to be x is negative 2. Guess how much going to be y? 0. Okay. Now we need to check if it has y-intercept. Looks like it's somewhere down the road. And that's why I tried to make it looks like it's gonna cross, and it didn't look good. But I'll try to do now more natural way, this way. Okay, and we know that down the road it will cross because it's spreading on the sides. Well, we can find out how much it's gonna be. So to find where it's gonna cross at the y-axis, then we have to take x is equal 0, right? Then y-intercept is equal -3 times 0 plus 2 squared. So from here, y-intercept is equal 2 squared is 4, 4 times 3 is -12. So it's going to cross somewhere where y is equal -12. And we don't have x-intercepts, right? Because it's going down and vertex is laying right on the x-axis. Okay, so we solve the one that has two x-intercept crossing x in 2 points. We solved one that has only one intercept. Now let's solve the one that doesn't have any intercept. The one that doesn't have any intercept. Okay. Which one it's gonna be? I'm going to build the graph 4 times x cubed, x minus 3 squared plus 1. Or would be much better if I put plus 5. Okay. So y is equal 4 times x minus, well, let's this time put 1 over 4. Everywhere we have whole number. Let's do 1 over 4. There we go. 3 squared and then plus 4. Okay. This is how our graph gonna look like. Okay. So if this is my going to be my x squared, so 1/4 is going to be 1/4 x squared. All right. So we are going to shift x, I'm going to shift by +3, and y I'm going to shift by +4. So let's, since we practiced enough, we are going to, let's go do at the same time. 1, 2, 3 here, and 1, 2, 3, 4. So I'm going to move here by 4. All right. And the graph is gonna look like, I'm running parallel. Well, it's a little bit here too. Maybe this one looks nicer. Okay. This is 1/4 x minus 3 squared plus 4. Okay, it's too thick this, so let me. All right, and our vertex obviously is going to be minimum, right? What is going to be vertex? 3 and 4. Here is 3, this is 4. +3, +4. As we can see, doesn't have any intercept, x-intercept, but it's crossing somewhat at somewhere y. Let's see where it's crossing. So to find out y-intercept, we take x is equal 0, and y is going to be equal 1/4. 0 minus 3 squared plus 4. Let's figure it out. Y is equal 1/4 times 9 plus 4. So it's going to be y-intercept 9/4 plus 4. So 9/4 is the 2 and 8, 2 and 25. 225, it's going to be 6 and 25. So approximately looks like 4, 5, 6 and 25, this point. Okay? 6 and 25. All right. So this was non-standard form. Now let's move to building standard form. So, by the way, range and domain, we already know, right? Let's see. Since we are going from infinity to infinity, x is going to be negative infinity to positive infinity, right? Range here, let me write down. And range is going to be what? We have 3, y is 4, correct? 4, and the other point is infinity, correct? Positive infinity. Therefore, since 3 is included, we are writing down, 3, keep saying 3. 3 is x. 4 is y for the point. 4 and infinity. In this case, what it's going to be? It's going to be y at this point here for range. Y here 0, and the other one is going to be negative infinity, right? So the range for here, it's going to be, so what is a smaller? Negative infinity. So first we put negative infinity, and we put in parentheses, because negative infinity doesn't have any limit, and it's come till -2. Square bracket because included. And domain is going to be negative infinity, positive infinity, because value of x, right? It goes from negative infinity to positive infinity. In my next video, I will record part 2, which will represent standard form, how to find vertex, y-intercept, x-intercept, and build the quadratic function. Okie dokie. Thanks for watching. See you in my next video.